Have you ever needed a trusted third party to hold money during a transaction? That's where escrow comes in. An escrow smart contract automates this process on the blockchain, making it secure and transparent. In this guide, we'll learn how to create our own escrow smart contract from scratch. We'll set up our development environment, write the contract's code, and deploy it to a local blockchain. Then we'll interact with it, simulating a real-world escrow transaction. Let's get started. This guide assumes you have a basic understanding of blockchain technology. However, even if you're new to this, don't worry. We'll explain everything in simple terms. By the end, you'll have a solid foundation for building more complex smart contracts. This tutorial will be hands-on, so I encourage you to follow along with each step. Learning by doing is the best way to master smart contract development. Let's dive in and start building our escrow smart contract. Before we start coding, we need to set up our development environment. This involves installing the necessary tools to write, test, and deploy our smart contract. We'll be using Node.js, Truffle, and Ganache. First, download and install Node.js from the official website. Node.js allows us to run JavaScript code outside a web browser. Next, we need Truffle. Truffle is a development framework for Ethereum that makes building and managing our smart contracts much easier. Open your terminal or command prompt and run the following command npm install gtruffle. Finally, let's install Ganache. Ganache provides us with a personal blockchain for testing our smart contract locally before deploying it to a live network. Download Ganache from the Truffle website and install it. With Node.js, Truffle, and Ganache installed, we're ready to start building our escrow smart contract. Now that our development environment is ready, let's create a new Truffle project. Open your terminal and navigate to the directory where you want to create your project. Then, run the following command truffle init. This will create a new directory with the basic structure for our Truffle project. Inside this directory, you'll find several folders including contracts and migrations. The contracts folder is where we'll store our smart contract code. The migrations folder contains files that help us deploy our contract to the blockchain. Let's create a new file named escrow.sol inside the contracts folder. This file will contain the Solidity code for our escrow smart contract. Solidity is the programming language used to write smart contracts on the Ethereum blockchain. Open the escrow.sol file we created earlier. Let's start by defining the contract and its basic structure. Pragma Solidity Circumflex 0. 8.0. Contract escrow / contract logic will go here. The first line specifies the Solidity compiler version our contract is compatible with. The next line defines our contract named escrow. Inside the contract, we'll define variables to store the addresses of the buyer, seller, and arbiter, the neutral third party. We'll also create a variable to track the value of the transaction address public buyer, address public seller, address public arbiter, uint public value. We'll add a constructor function to initialize these variables when the contract is created. Constructor, address underscore buyer, address underscore seller, address underscore arbiter, uint underscore value. Buyer equals sign underscore buyer, seller equals sign underscore seller, arbiter equals sign underscore arbiter, value equals sign underscore value. This constructor function takes the addresses of the buyer, seller, and arbiter, along with the transaction value, as arguments. Section 5. Deploying your contract to the blockchain. With our escrow contract ready, let's deploy it to our local blockchain. First, open Ganache and make sure it's running. Ganache simulates an Ethereum blockchain on our computer, allowing us to test our contract without spending real ether. Next, we need to configure Truffle to connect to our Ganache instance. In your Truffle project directory, create a new file named truffleconfig.js. Paste the following code into this file. Module. Exports, networks, development host 127.0.0.1, port 7545 / default Ganache, port network underscore ID, * / match any network ID key. This code tells Truffle to use our Ganache blockchain when we deploy our contract. Now let's create a migration file to deploy our contract. In the migrations folder, create a new file named to_deploy_contracts.js and add the following code: const escrow = artifacts, require, escrow, module, exports = function, deploy, escrow, buyer address, seller address, arbiter address, value, replace, and with the actual addresses and transaction value you want to use. Finally, open your terminal, navigate to your Truffle project directory, and run the following command to deploy your contract. Truffle migrate. If everything goes well, you should see a message indicating that your contract has been deployed successfully. Section 6. Interacting with your contract, the Truffle console. Now that our escrow contract is deployed, we can interact with it using the Truffle console. The Truffle console allows us to call the contract's functions and interact with its data. Open your terminal and run the following command, Truffle console. This will open the Truffle console, which is connected to our Ganache blockchain. To interact with our contract, we first need to get its instance const escrow =await escrow.deployed. Now we can call the contract's functions. For example, to get the buyer's address, const buyer =await escrow.buyer, console log buyer. This will print the buyer's address to the console. We can also call functions that modify the contract's state, such as releasing funds to the seller. Section 7. Funding the escrow contract. In a real-world scenario, the buyer would now fund the escrow contract with the agreed-upon value. We can simulate this in the Truffle console. First, make sure you have enough Ether in your Ganache account. Next, use the following code in the Truffle console to send Ether to the contract's address. Web3. Etherot send transaction from buyer address to escrow address, value, Web3, utils, to away, 1 Ether. Replace with the actual buyer's address and with the desired amount of Ether. This code will transfer 1 Ether from the buyer's address to the escrow contract's address. Section 8. Releasing funds, completing the escrow. Once the buyer has funded the contract, the seller can fulfill their end of the agreement. Upon successful completion, the funds can be released from the escrow. To simulate this, we'll add a function to our contract solidity function release funds, public. This function allows the arbiter to release the funds to the seller. Redeploy your contract after adding this function bash truffle migrate. Now, in the Truffle console, you can call the function as the arbiter JavaScript await escrow.release funds from arbiter address. This will transfer the funds from the contract to the seller's address, completing the escrow process. Section 9. Monitoring transactions with Ganache. Ganache provides a user-friendly interface to monitor transactions happening on our local blockchain. After deploying and interacting with your contract, you'll notice new blocks being added to the Ganache interface. Each block contains the transactions executed, including the deployment of your contract, funding the escrow, and releasing the funds. Clicking on a transaction shows its details, such as the sender, recipient, value, and gas used. This allows you to understand how your contract interacts with the blockchain and track the flow of Ether. Section 10. Troubleshooting and common issues. While developing smart contracts, you might encounter errors. Here are some common issues and troubleshooting tips. Double-check your Solidity code for any syntax errors or typos. Ensure your Truffle configuration is correct and that Ganache is running. Verify that you have enough funds in your Ganache account and that the transaction parameters are correct. Carefully review your contract's logic to ensure it functions as intended. If you're stuck, don't hesitate to search online forums or ask for help in the Truffle and Solidity communities. Section 11. Conclusion and next steps. Congratulations, you've successfully created and deployed your own escrow smart contract. You've learned how to set up a development environment, write Solidity code, deploy a contract, and interact with it using the Truffle console. Remember, this is just the beginning. You can expand your escrow contract by adding more features, such as dispute resolution mechanisms or support for multiple participants. Keep experimenting, exploring the world of smart contracts and blockchain development. The possibilities are endless.